Hello, we are going to determine the center of gravity of an irregular lamina. Before that, what is a lamina? Well, any plane surface like this happens to be a lamina. This particular lamina is rectangular in shape. So, the center of gravity is well defined. It will be the intersection of the diagonals. So, when you draw the diagonals, then this point becomes the center of gravity of this lamina because this is symmetrical. But what if we have an irregular lamina like this? Then we obviously cannot say that the center of gravity will be intersection of the diagonals. So, what we are going to do is we are going to determine the center of gravity of this irregular lamina. For that, obviously this lamina is with me and I will need a plumb line. First of all, what we need to do is we need to pierce 3 holes in the lamina so that they are forming the 3 vertices of a triangle. So, here this is the first hole and then the second hole and third hole. So, you all can observe that the 3 holes are the 3 vertices of any triangle, and then we will proceed to pass a string through it. Here we have put a thread, we have tied a thread from one of the holes, and this will be suspended from any kind of a nail that is there. Right, it should be vertically straight like this, but since it is tight, it is tilting slightly. Here, this is the plumb line. This is used by masons to see whether the wall is vertical or not. Maybe you all have seen this before. So, this is what we are going to use. We will suspend it in front of the lamina like this, right? And then we will put a mark just behind the thread of this plumb line such that the line is not visible. Well, I have put a small mark over here, and now we will draw a line such that the line is passing through the hole as well as the mark that we have put. Now, we will remove it from here, and the string will now be tied, will be passed through another hole. You can take any particular hole. Again, suspend it from the nail. So, now you can observe that the lines that we have drawn have intersected at this point. So, this obviously is the center of gravity. So, I have been able to obtain a point where the 2 lines intersected, which I am saying is the center of gravity. Then, what is the use of the third hole? When I repeat this with the third hole, we will find that the line, when we use the third hole, passes through the same point. So, that will show that this is the center of gravity. So, let us repeat it through the third hole also. Well, I have put a mark and let's draw the line through the third hole also and see. So, this was the hole and this is the mark over here, and you can observe that well it is passing through the same point again. So, this proves that this point is the center of gravity of this irregular lamina.